Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are student preparing for competitive exams like JEE, NEET, and other entrance tests, or you simply want to build a strong command over chemistry concepts, then you are just landed in right classroom. So grab your notebook, stay focused, and let's begin our journey of mastering chemistry, one concept and one question at a time. Let's get started. Our today's topic is physical quantity and its measurements. So there are not only single quantity, there are a lot of physical quantities. Before going into uh, physical quantities, what are those? Let us first know that what is a physical quantity. Actually, physical quantity is a physical property of a material or a matter that can be measured by or that can be quantified by measurement, and their measurement does not involve any chemical reaction. So what they want to say is that we are not going to use any chemical reaction. Whatever properties which are related to their physical nature, like odor, area, volume, pressure, these all properties are physical quantities. Okay, so physical quantities can be anything. You should know there are a lot of physical quantities. Let's talk about them. Let's talk about how to measure it. So, physical quantity or the magnitude of physical quantity. Magnitude of physical quantities. Any physical quantity, we can talk about any physical quantity. Okay, it is equal to, there are two things which should be remembered when we are talking about the magnitude of physical. It has two things, that is, one is unit of physical quantity and other one is its numerical value or any number which is associated with this physical quantity. So what is magnitude of physical quantity? It is actually multiple of these both, unit multiplied by numerical value or numeral, you can say. So let's talk about a lot of different physical quantities which we are going to see, and what are the basic physical quantities which we are going to see number of times in chemistry. So there are actually 7 in total physical quantities which are basic physical quantities, and rest one are actually multiples, or they are present in any kind of factor with these 7 physical quantities. So first one is length. Okay, second is mass, third is time, fourth is electric current, right? Fifth is temperature, or specifically thermodynamic temperature. Sixth is amount of substance. And seventh one is luminous intensity. Okay, All these seven physical quantities have been given a few symbols. Okay, we have to know those symbols. For example, for length, it is small l. For mass, it is small m. For time, it is small t. For electric current, it is capital I. For temperature, it is capital T. For amount, it is small n. And luminous intensity is IV. I can be written capital I and V. Okay. Now let's talk about their units. Before knowing about their units, we must know that what is a unit and what kind of units we have been given by different scientists. So what is a unit? Unit of a physical quantity. Okay. So unit can be defined as a standard of reference uh, chosen to measure any physical quantity. What is the meaning of it? Okay, so it is a standard which has been chosen uh, that is actually help in measuring any physical quantity, or during any measurement any physical quantity is measured in this kind of unit, that is called unit. Okay, it is that. So whenever like we have to take some mass, okay, so we will say that okay, I need 100 gram of something, so that gram is actually unit. Okay, which gives us the comparison of these two things for measuring a physical quantity. So units are of two types. Okay, one is called basic units and second one is called derived units. So there are two types of units, basic units and derived units. So let's know that what is the meaning of basic units. So first one was basic units. So actually basic units are the units of these seven fundamental properties which are present. Okay, so first fundamental property was length, right? Its basic unit is meter. Okay, and its symbol is m. The symbol of unit we am talking about. Now I'm talking about symbol of unit. Okay, unit is meter and symbol of unit is small m. Then there was mass. Okay, its unit is gram and it is represented as a symbol of small g. Then there was time. Its unit is second, which is represented as a small s. Then there is क्या था? Next one is thermodynamic temperature. Its unit is Kelvin and symbol is capital K. Okay, this is first one, this is second one, this is third one, and this is fourth one. Then there is amount. Its unit is mole, and its symbol is MOL. Okay. There is there is there is electric current. Its unit is ampere, and symbol is capital A. Last one is luminous intensity. Its unit is candela, like candle. It has come from candle, obviously, and it is CD. Its unit is CD. So these are the basic units. Next comes derived units. Actually, these units are derived from various fundamental units. So that's why they are known as derived units. Okay. Rest of the whatever unit we are going to use, like speed or velocity, okay, whatever we are going to use, that is actually going to be a derived unit, right? So it is derived using fundamental properties. Okay. Okay, so these are the some basic physical quantities and their corresponding SI units. Now you might be wondering what is the meaning of SI, right? So there are few ways to give the units. Uh, these are uh, various systems to represent various units of physical quantities, right? Now first one came out to be CGS system. Okay, so there are three words. Okay, C for centimeter, which is for length or distance. G for gram, it is for mass, and S is for second, and it's for time. So there was a system where only length, mass, and time was measured, and it is measured in centimeter, gram, and second respectively. So this system is called CGS system. Okay, the second one is FPS. F is for foot, P is for pound, and S is for second. So there was another system, and this was a British system actually. Okay, and here what they did, they actually measured length in foot, mass in pound, and time in second. So that is only fine. Okay, this was second system. Okay, the third system is MKS. M is for meter, K is for kilogram, S is for once again second. Okay, this was initially it was used like this. Once again, meter for length, kg for mass, and second for time. And later on periods, what they did, they actually added ampere to it also. Okay, which was, the unit of electric current. This was the third one. Now comes the fourth one. The last one, which is SI system. This is most widely used. This is International System of Unit. It is also known as System and International. So this is most common, you must remember. And it is actually favored by each and every scientist across the world. So it's not like some Britishers are using it, or a few people are using it, or it is not tailored according to some specific group, but it is tailored according to the everyone. So this one is called SI unit. So that's why we have used it over here in case of SI units. Whatever units I have told you earlier, they were in SI units. So length has SI unit of meter, mass has kilogram, time has physical quantity, unit second, electric current has ampere, thermodynamic temperature has Kelvin, and amount of substance is mole, and last one is luminous intensity, which is candela. So these all are the SI units of basic physical quantities or fundamental physical quantities. As we are talking about chemistry, so we are not going to use them in a large manner. Like if I'm talking about mass of a substance, its unit is in kilogram, so we are not going to take that in kilogram. Obviously, when I'm working with the physical chemistry or any kind of chemistry, we are going to use them in a very small amount. So kilogram is not going to be used, or gram is going to be used, or some other quantity, other term is going to be used. So for that, we actually learn about the prefixes of units. So sometimes there are certain quantities or certain numbers that are multiplied with these fundamental properties of your units, and then that quantity is converted into some other kind of. So this is the list of commonly used prefixes in the SI system. Okay. As we know, I think you must know that what is a prefix. Prefix means uh, it is, divided into two words, pre plus fix. It should be added or multiplied basically uh, before a unit. Pre means before. Okay, so these are few prefixes. Like first one is deci, symbol is small d, 10 raised to power negative 1. Then is centi, c, 10 raised to power negative 2. The multiple is given in front of you. So any number when it is given, like, okay, most of the time you might have heard about this number, 1 centimeter. So if I have to convert this centimeter is not a SI unit, it is a CGS unit. Okay, so it is represented in the CGS system. So if I have to convert this CGS unit into SI unit, then my length should be represented in meters only. So I will convert centi is 10 raised to power negative 2. So 1 multiplied by 10 raised to power negative 2 meter, 1 centimeter. Okay, if 30 centimeter is given, then 30 multiplied by 10 raised to power negative 2 meter. So meter is actually SI unit and centimeter is CGS unit. Okay, you should remember that. So that's why these prefixes are used. Next is milli you know that millisecond or milliliter or these kind of things are given. So what is the meaning of milli? 10 raised to power negative 3. Then there is micro. You might have heard about microwave. Okay, micro means 10 raised to power negative 6. Their waves have the size of 10 raised to power negative 6. Then there is nanotechnology. Now we are talking about nanotechnology a lot. So the whatever we are going to do, whatever kind of research we are going to do, the size is going to be 10 raised to power negative 9. That is why it is nano. Then there is pico, 10 raised to power negative 12, femto, 10 raised to power negative 15, atto, 10 raised to power negative 18, zepto, 10 raised to power negative 21, and 24 is yocto. Okay, and if these multiples are in positive, okay, then they are deca, hecto, kilo. Okay, kilogram. Most of the time you talk about kilogram, right? Or kg. Kg is the k is the symbol of that. So if I have to convert this k into, right, this kg is SI unit, but if I have to convert this SI unit into CGS unit, which is gram, then what I'm going to do? One is the numeral part or numerical multiplied by 10 raised to power 3. So this is 1 kilogram is equal to 10 raised to power 3 gram. So that is kilogram. Then there is mega. Okay, then there is giga. Most of the times whatever you do, you use data that is in GB, or sizes of memory that is in GB, right? Nowadays terabyte GB is also given. So the powers which we are talking about, the sizes which we are talking about are 10 raised to power 9 in giga and 10 raised to power 12 in tera. That is a huge size. Then there is peta, then there is exa 10 raised to power 18, zeta 10 raised to power 21, and iota 10 raised to power 24. So these are the prefixes which are added in front of the SI system, SI units, so that those units can be converted from one type of system to another type of system. And that's all for today. And I hope you have understood the concept and also gained confidence in solving the competition level questions. Thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.